the pancreatic duct and the common bile duct fuse to form the blank. Good. Sphincter of Oggi, or I actually use the correct term now, even though that's the fun one. Hepatopancreatic ampulla and sphincter. All right, those two. I'll show you how that works when we get to this slide, but that's the first question. The fusion of the pancreatic duct and the common bile duct form the hepatopancreatic ampulla and sphincter. I'll show you what that looks like, but that's just the first one. You guys will bang it out. It's about 40 multiple choice, 15-ish matching. I took it in 12 minutes this morning. All right, so you guys, it's something you can do. It's I went right through it, didn't find anything that stumbled me or tricked me or thought that's going to be, nope. Just I think it's pretty straightforward, completely comprehensive. It's on one chapter. It's digestive. So I think you guys, most of you guys will be out of here in less than an hour easily. Let's start with the practical. Remember, there's going to be 3 models back there, so we'll probably start over here with Marissa this time, just to make it fair to everybody, and finish up with Billy or whoever's sitting in the back there. 3 models in back, and we're going to start out with the slides up here, and then I'm going to go through the PowerPoint slides and images today, and we'll just make sure to talk about it and cover Heather. Those were great questions, and I wanted to let everybody know at the same time today, and if we don't cover them, we'll come back to them and bang them up. Let's start out with histology. Any questions before we get going? All right, good. Next time I'll see you, we'll have a test, and then we may already. And we're winding down the backside of AMP3, which is amazing to me how fast this year goes. Oregon.
Oh, digestive system.
No, we're in the systems, we're close. Let's not have this one tripped up. Would you say it's fairly flat across the top there, or, yeah, that's the stomach, that's the stomach. Yeah, these are different slides, I mixed them up on you today, so you guys are thinking, wait a minute, that's not the slide you know. There's a whole bunch of Google image slides for stomach. This is actually the stomach. This is the gastric pit here of the stomach. What would be the pH in here? These are all questions I make up, the questions when I wake up in the morning. So yeah, 2 to 4 is great, 1.5 to 3.5, okay. There's a range that I'm looking at up here. Can you name 3 of the 4 cell types that you might find here? Mucous neck cells, parietal cells, enteroendocrine cells, zymogenic and chief cells. Those are the 4 subtypes that are found in the stomach. All of those are on the exam because I took it this morning, and you need to know the function of each. All right, so they're very important. Paracrine and enteroendocrine are the same. All right, not to trick you. All right, that just means that they're releasing hormones is all the crine means. Para is next to. Paracrine cells are cells that are releasing hormones next to the given organ. I'll accept either. I use enteroendocrine on the exam and not paracrine. It's a more general term, and it just leads you to understanding that we're releasing hormones. Are we good with that? Good with that? All right, good. I don't think we can think of much else to be creative about on the stomach slide. Oh, is that pretty? That is pretty. What organ is this?
The liver.
The liver. All right, the liver. Cell type. Hepatocytes. Hepatic or hepatocyte is the cell type here. The predominant is in the liver. All right. There's one challenging question. I don't think it's challenging, but I think you guys will. Does the liver release enzymes?
No.
No. Good. No, it doesn't. I think you guys think that it releases enzymes for some reason, but it detoxifies. Let's list down functions of the liver. It detoxifies. It makes cholesterol.
it secretes bile. Is bile an enzyme? Bile is not an enzyme. Bile is an emulsifier, all right? I don't think I need to say this, but if I'm talking about it, it's on the exam, all right? So all of the things I just mentioned are part of the exam in some format. This special unit or subunit of the liver is called the blank. Triad. Good. Can you name the three vessels of the triad, please? Boom. Number one. Portal, arterial. Why would I point to this of the three?
Because it has a small lumen.
Small lumen and large tunica media, which is surrounding it. This is the portal venule, large lumen, small tunica media. And the third part of the triad is the bile duct. Bile duct. Good. That's pretty. Organ, always start to try to give you some orientation so you can kind of focus in on where are we. What organ is this? Small intestine, beautiful. In the lumen of the small intestine, enzymes function best at what pH? 7, beautiful. 3 modifications of the small intestine that increase surface area for absorption. Number 1, plica. Plica, which is this fold in here. Number 2, villi. Do we have a villus model?
Yes.
There's a green thumb going up the middle of the villus model. You guys seen that? Big green piece, part of the lymphatic system. Anyone know its function? It's called a lacteal. It's listed on your objectives. Probably take a look at that. All right, the green thumb in the middle of the villus model is called a lacteal, and it is provided for the absorption of fats. Fats. The third modification in the small intestine that increases absorption. Good, that's it. Excellent. Third modification are microvilli. All are considered modifications of the mucosal layer. These are so pretty, these slides, I think. Organs.
Pancreas.
Pancreas. Specific cell type of the pancreas. Islet cells. Islet cells. There's 2 subtypes, 1 and 2 up here. Number 2 are islet cells, and they function in blank homeostasis. Blood sugar, because they release insulin and glucagon. We good with that? You don't need to know the difference between alpha and beta cells. Don't worry about it. Second, what type of cells are these? Acinar cells. A-C-I-N-A-R, acinar cells. They release 2 important secretions. Name them. Good. Important. 1, alkaline pancreatic juice. Number 2, enzymes, pancreatic enzymes, which are triggered by CCK and secrete. If I told you these were endocrine, the acinar cells would assume to be blank, exocrine, because they're secreting into the pancreatic duct, which will eventually go through the hepatopancreatic sphincter and into the duodenum. Histology, did you write all that today? Holy cow. Histology of the pancreas, those are our 4 histology slides. Any questions on that? You do okay on that? You guys gonna be ready for this one? Kinda rainy this weekend, have you guys studied? Maybe not, I don't know. Alright, just gonna go through these images like we usually do, and I've got my very thorough cheat sheet here this morning. Make sure we get it all. I think about half of these are pretty straightforward. If you've been here and been awake, you'll be fine. I ask you kind of to draw this as you're going through. We can start out here in the mouth and then we'll go through, but terms that you should be aware of, starting in the mouth. Mastication, which is chewing. Function of saliva. Anybody know? Moisten food, protection or cleansing of the mouth, breakdown of carbohydrates, optimal pH, 7. pH is important. There's a matching section on the back of the test. You guys remember the enzyme lab? I would review it because each enzyme that was covered in that lab is on the exam. And I also ask you optimal pHs, all right? So salivary amylase, released in saliva, optimal pH of 7, functions to break down carbohydrates. Can you tell me the rest about things like pepsin, pancreatic amylase, lipase, nucleases? Those are all enzymes we'll get to today. Good. Off of this slide, it talks about the GI tract, and there's several things that are on the exam. You'll need to understand terms like chemical digestion. So there's a section where we talk about, do you know the difference between absorption, digestion, hydrolysis? These are all on the terms. Exam, if you don't know what the terms are, you should look them up. So we got digestion, absorption, hydrolysis, peristalsis, defecation. Couple of questions I'm thinking of that I don't want you to get tricked on, but what's the main function of the small intestine? Absorption. All right, absorption. What's the main function of the large intestine? Get rid of waste. All right, dry out waste. Not water absorption, not absorption of other chemical or food stuff. It's to get rid of waste. I don't find that tricky, but I don't want you to. How many layers in the alimentary canal? Alimentary just means the GI tract. And as you go through it, it has 4 layers. You'll need to name them in order from the inside to the outside. That is mucosa, submucosa, tunica muscularis, and the serosal layer. Those are 4 layers of the alimentary canal, or the GI tract. Absorption takes place in which of these 4 layers? Number 1, 2, 3, or 4. Absorption takes place in the mucosa, submucosa, external, or serosal. Because those are where we have our absorptive cells in the small intestine. Of these 4 layers, which ones contain blood vessels and lymphatic vessels? Submucosa, the second layer. And what modification of the tunica muscularis occurs in the stomach?
Extra
Extra layer called the
oblique.
oblique. All right, if you're not familiar with all of these things I'm talking about, you'll want to look them up for sure, or make sure you're comfortable. How many adult teeth are there? 32, and the last 2 emerge are the blank. Wisdom teeth. Wisdom teeth. Test question. How many primary, also known as deciduous or baby teeth, are there? 20, and usually have emerged by blank. 2, yeah, 2 years, typically. I'm thinking, didn't see anything on tonsils, didn't see anything on papillae. I can remember, there's some teeth. Hardest material in the body is considered the blank. Enamel. Is tooth a bone?
No.
It is not. Good. You'll be fine. Oh, this is pretty. Understanding where we're at here histologically, I could use this slide. Coming over here, I like it. But you know what this organ is?
Oh, it's the esophagus.
Esophagus. And what kind of tissue lines the esophagus? Stratified squamous, because the food's there and it causes friction. But as soon as we move into the next organ, which is the blank stomach, it changes to simple columnar. Simple columnar. Good. That's the gastroesophageal junction slide. Would you expect to find in the tunica muscularis, would there be a thickened sphincter here?
Yeah.
Good. Bring a coin. Yes or no? Absolutely. There's a sphincter at the top of the stomach to prevent gastric juice from moving back up. All right. There's also at the base of the stomach the pyloric sphincter, which is a thickened muscular layer of the tunica muscularis. Things to know about the stomach that I'm recalling. The extra layer I mentioned earlier is the oblique, so that's probably on the exam. The folds in the stomach that allow you to supersize your McDonald's meals is called ruga. Ruga. The sphincter at the distal or terminal end is the pyloric sphincter. You guys remember the term distal and proximal? They actually come back, we use that in context of bone. When you're standing up, distal and proximal, when we study bone. We actually use distal and proximal again now with the digestive alimentary canal. And so distal would be down the pipe, where proximal would be toward the top. You understand what I'm saying? So the pyloric sphincter is our distal sphincter of the stomach. Good. So if you're taking notes, these slides are gonna go through each organ, and I'm basically
basically telling you what I've asked you about each organ. When you get to the stomach, then it is lined with simple columnar, for sure. It has the extra oblique layer here, on the inside. And then we have 4 cell types. Those 4 cell types are mucus, neck, parietal, zymogenic, and enteroendocrine. You'll need to be able to, I want you to write, let's write these 4 out. You had a chemical worksheet to do that Heather put a few things on it. I wanted to make sure we cover them. When you see these 4 cell types, you absolutely have to know what their function is. So when we get to the stomach, I already told you the anatomical modifications of the pyloric sphincter, the oblique muscular layer, the ruga that lines the inside and increases surface area but allows for expansion, not absorption. Do we absorb in the stomach? No, nothing really. There's a question I thought, well, they might get this from I think the thing is about the stomach, and one of the answers is the first place where absorption takes place. Is that accurate? No, it's not at all. Really, you could argue that there's a little bit in the mouth, correct? Chemical absorption occurs there, but absorption doesn't really occur in the stomach as far as we know, so don't answer that one. But then you have to list out these 4 cells and be explicit about understanding what they do. Now, mucus neck cells are easy. What do they make? Mucus, okay, but give me the function of mucus. Why do we make mucus in the stomach? Protects against the acidity, all right? That's why we make mucus. So that's the name of the cell, what it does and its function in the stomach, all right? Next one would be enteroendocrine cells. What do they make? Hormones, good. Do they release their hormones into the lumen of the stomach or into the bloodstream? Into the bloodstream, the bloodstream. Then we have our parietal cells. Parietal cells make what?
Couple things.
Couple things. I like that. 2 things, all right? One is what? Hydrochloric acid,
Sodium.
all right, or hydrogen and chloride ions is actually the most accurate thing. And then the second one is intrinsic factor, and if you haven't written that down, you better, because it's on the exam. An intrinsic factor is helpful to absorbing blank. Vitamin B12. All of this is on the exam. There's a question you guys will just go, whoops, circle, easy, know that one. Intrinsic factor is important for absorbing vitamin B12. Answer D. Why do we have hydrochloric acid?
Breakdown, food, or digestion.
Yeah, that's we're getting there. Why do we have an acid pit there? 2 major things why we have acid. 1, Michael. Good. That's my first one. It's our immune. It kills stuff. We have a big pool of acid that whatever tuna sandwich you're eating from Subway is gonna go into your stomach, and we're gonna kill most bacteria because it's a pH of 2 to 4. Y'all with me on that? That's 1 major function of the acid in the stomach. Number 2, activating enzymes. What enzyme is activated in the stomach by a pH of 2? Pepsinogen conversion to pepsin. We did the lab. Pepsinogen is converted to an active enzyme by this high pH. And pepsin starts breaking down blank. Protein. It's the first site, really, of some type of significant digestion. Yeah, there's salivary amylase. Yeah, there's salivary lipase. Pretty sure nobody in here chews for 30 seconds. Maybe you do. If you do, good on you. You have better digestion. The process of enzymatic breakdown of foodstuff is called what? It's on the test. The process of enzymatic breakdown.
Chemical digestion.
Nope. Hydrolysis. It is part of chemical digestion. Using water to break up molecules is what enzymes does. And it's called hydrolysis. It is a major part of chemical digestion.
He said the whole thing is a process of enzymatic breakdown.
The process of enzymatic breakdown of foodstuff is called hydrolysis, using water to break down molecules, critical to chemical digestion. You guys getting all this? It's all on the test. All good stuff.
Aye, yeah. Don't worry about inhibitory events. Didn't put those on the exam, which is the right side of this chart. However, the rest of it, you'll wanna have, this is the physiology, the kind of the tough part about the exam. Cephalic, gastric, and intestinal phase. Which of the three, I put all, these three phases are on the exam. When you think or smell food, that activates which of these phases? Cephalic, yeah, cephalic, in the brain, sight and thought of food, there it goes. You need to know always, the only cranial nerve on this exam is vagus, as usual from here on out. Vagus is involved in everything. That's all you need to know about cephalic phase. Gastric phase is when most chemical digestion and release occurs, is during the gastric phase, when food actually comes down and distends the stomach. We have vagal stimulation and we release gastrin to begin secretion in the stomach. Huge. And then the intestinal phase is when we actually are moving food into the intestine and we're encouraging the stomach to continue its breakdown of food stuff. 3 phases of gastric secretion. Cephalic, gastric, intestinal. You'll notice on your chemical worksheet, and you kind of started bringing that up last night, Heather, good question. Here's gastrin from the stomach. We also have another gastrin. Gastrin's a hormone, if you don't know that, all right? Comes from the G cells, and you asked that, Heather?
Yeah.
You asked about G cells?
Yeah.
G cells is just the specific enteroendocrine cell that releases gastrin.
Thank you.
That's all the difference.
Thank you.
There are 2 sites of gastrin release, the stomach and the intestine. If it comes from the intestine and is placed in the bloodstream, it's called enteric gastrin. Here's the parietal cell. Here's our friend gastrin. One of the triggers to making or manufacturing hydrogen and chloride in the stomach at the parietal cell, we already talked about parietal cell today, is gastrin. Gastrin's a hormone. Comes from enteroendocrine cells of the stomach and enteroendocrine cells of the intestine. Also, 2 other triggers for HCl production. Acetylcholine. Anybody know where that comes from? What cranial nerve have we been talking about? I said the only one. It's vagus nerve, please. It's acetylcholine. And histamine. Do you want to remember, this is not a, that's never mind. I'm not even gonna talk. On that. We draw a line, we're out of the stomach now. And we've moved down, this is where the pyloric sphincter is. We move down into the small intestine, the pancreas, and the gallbladder. Let's start out with the easy one, gallbladder. Function of the gallbladder.
stores bile, does not secrete bile. It stores and releases bile. Second function of the gallbladder, it concentrates bile. When we say we concentrate something, what are we removing from it? Water. Pulls water out. If you pull out too much water, you'll get blank. Gallstones. And the current treatment for gallstones? Lithotripsy. It's all on the test, that's what I'm saying. I'll say that maybe the last time, maybe I'll say it about 5 more times. But all of those things I just talked about are on the exam. Lithotripsy is the treatment for gallstones. Gallstones are caused by over concentrating bile. Where was that bile made? It's up in the liver. So the liver's up here. Here's the right and left hepatic ducts of the liver. Liver sits up here on the top. We've got our hepatocyte, and it's making bile. And it comes down here and comes down and wants to come through the hepatopancreatic sphincter and ampulla. Ampulla is just the enlargement down here at this side. Hepatopancreatic ampulla and sphincter also used to be called the sphincter of Bodi. But this sphincter sometimes is closed. Because if there's no food in there, there's no need to waste the bile. Y'all with me on that? So we close it. And that bile then backs up into the cystic duct, which will push the bile into the gallbladder until we need it. Then all of a sudden you eat that Big Mac and fries and Diet Coke, and it comes down into the duodenum, and we reach out and cause the gallbladder to contract. Because we have to break down the lipids, the fats. What hormone is released from the small intestine? It causes the gallbladder to contract. That's where we get into the hormones. You better know your hormones and enzymes. That chemical worksheet is all over this exam. The specific hormone that causes the gallbladder to contract is CCK. Huge.
CCK by itself or CCK and secretin?
Just CCK. Targets. Is there a line on your chemical worksheet that says target cells? Target cells of CCK is the pancreas and the gallbladder. Secretin is the pancreas and the liver. Also, you just ate this meal. We need to contact the pancreas. CCK goes to the pancreas. And we release what from the pancreas now? Enzymes and pancreatic juice. Because we're flooding the duodenum with the Big Mac and fries and a Diet Coke. What's the pH of this chyme entering the duodenum? 2 to 4. Is that good? Does our intestine like that? It does not like that. It calls for help immediately, and the pancreas releases pancreatic juice, which is alkaline, and will buffer that. So as we're moving this Big Mac and fries to here, it's now back toward a pH of 7. We're all good with that? CCK, secretin, 2 important hormones, both heart tissue and specific function. First question on the exam. The common bile duct and pancreatic duct come through the hepatopancreatic ampulla here. Also, you should be aware, because I did use this as a possible multiple choice answer, if we're having a problem releasing pancreatic juice, we do have a backup pathway called the accessory pancreatic duct, which is right here. To bring it full circle, have you seen the histology of the pancreas? Didn't we start with that this morning? Can you name 2 cell types that are here? Islet cells and acinar cells. Which of the 2 cells are affected by CCK or secretin? Acinar cells, because they're releasing enzyme and pancreatic juice. Good.
already went through this, small intestine, there's a nice picture of it. If there are 4 cell types that line the stomach, how many cell types line the small intestine?
Same for
3. They're called absorptive cells, goblet cells, and enteroendocrine cells. What do the enteroendocrine cells release? Hormones is a good guess. What specific hormone, please? It's on your chemical worksheet. It's called enterogastric. Enterogastric. Conceptual questions. Liver. Here's our triad. Portal, arterial, venule, and bile duct. Have we already seen these? Okay, all right. Bile duct carries what? Bile. No big problem there. Bile's made by hepatocytes. Go with me on that? Where's it headed? Where's this bile duct going to go? Hepatic ducts, backs up into the gallbladder, or goes directly into the hepatopancreatic angle. Portal venule. Where's that blood come from? It's important you gotta make this connection by Wednesday. Portal venule. Where is it? You guys, you can tell me, we just had to identify it. And now I gotta know what it does. Well, yeah, a little bit. Where'd it come from? What's the function of the liver? Again, big picture. Clean, it does. Comes from the small intestine. Michael, very good. Because what happens is, what's the function of the digestive system that we're covering? What's the big function, big picture? Easy? Digestion. Absorption of food, correct? Well, this is bringing food from the intestines into the liver. Is it clean or dirty? It's dirty food. You just made that tuna sandwich on your counter at home. You haven't wiped down that counter for 2 days. All right? It's bad news. And instead of just absorbing whatever you eat and putting it right into circulation, wouldn't it be nice if you put it through our filter first? And so this blood in the portal venule is coming from the small intestines where we just absorb food. And it comes through the liver for cleaning. And eventually, the blood down here in the central vein is cleaned. And one of the functions of the liver is storage. So we'll pull out maybe some amino acids from that tuna sandwich, maybe some sugars, glucose. Do we store glucose in the liver? Tons. All right, so we got to get that from somewhere. All of this food is rich in nutrients and rich in waste. Blood leaving the liver through the central vein, which eventually becomes the hepatic vein, which comes back in the inferior vena cava, is lower in waste materials because we processed it, and lower in nutrients because we stored them. Are we clear on that? Good. The portal arterial is simply bringing oxygen into the cells. Would you expect liver cells to have a high oxygen requirement? Yeah, they actually are what heats our blood, and they're working full time. So we supply them directly with arterial blood, high in oxygen, so that they can metabolize. It's the only site in the body where, if you notice, arterial and venous blood mix. That's called a sinusoid. Write that down, please. Sinusoid of the liver. sinusoid. Sinusoid. Site in liver where we mix oxygen rich and oxygen poor blood.
always like this picture, one of my favorites. Kind of shows the whole picture up here. We come down with food, we fill it up, ruga stretches, got chyme being formed, goes into the duodenum. When we get into the duodenum, duodenum says time to go to work. Time to go to work. What hormones are released from intestinal mucosal cells right here, mouth, stomach, intestine. Shailene finally says, food's coming down, I'm gonna send out 3 hormones. Anybody name 3 hormones that Shailene's gonna release? CCK, secrete, enterogastric. 3 hormones. You guys in the class are the accessory organs. Where's gastrin going? If Shailene's sending out a help signal, hey, this is how it works. You gotta visualize, it's an easy test. I took it because I can visualize. Here's the mouth, here's the stomach, here's the intestine, food's coming down. Did they do anything, this group here, in the stomach? Maybe chunked up a little bit of protein and maybe killed off some things that were lingering on that tuna sandwich because its pH is 2 to 4. Is that right? Not much. And then they liquefied. Y'all with me on that? 3 layers of the smooth muscle, and they send it down the intestine. Julian's not happy. She's gonna have to go to work right now. And she's gonna send out for help. She sends out 3 things. Enterogastrin, where's it going? Right back here. Gastrin goes in the stomach and creates gastrin. Picture it, targets the parietal cells to make hydrochloric acid. So it tells these 2 to keep working. Keep working. Shailene also sends out CCK and secretin. Where's it going? Well, these are all hormones. So she doesn't send it into the inside of the intestine. She sends it the other way. Rochelle, which is in the bloodstream. And Rochelle sends out CCK and secretin. Can you tell me what the target tissue is? What it does at the target tissue? All right. So let's start with CCK. It's 1 hormone. Shailene's like, all right, everybody wake up, wake up. CCK's coming out, it's in the bloodstream. That means it's going systemically, it goes all over. 2 target tissues of CCK. Number 1, gallbladder. Brittany, you're the gallbladder. This CCK goes out, goes over to Brittany, and causes the gallbladder to contract. That's function of CCK. CCK also goes to the liver. Alicia, you're the liver. Goes to the liver. What's it going to cause Alicia to do? Anybody know? Make bile. Does Shailene eat bile? Tuna sandwich. Right here. Needs bile. Break down fat. And emulsify fat. Sorry, not break down, emulsify fat. And bile is alkaline. Because isn't this chyme coming in acidic? You guys see what I'm doing here? Can you put all this together? If you can, it's an easy test. Easy test. What else does she release? Secrete. Secrete. Oh, did I just say that? Oh, I made a big mistake. Talking too fast, thinking too fast. CCK never went to Alicia. CCK went to Brittany. Go back in your notes real quick. CCK target tissue, I'm gonna make this right. CCK target tissue, Brittany, gallbladder, and Michael, pancreas. Sorry,
Not the liver.
not the liver. CCK does not go to the liver. My bad.
It says that in
Says what?
your liver.
Liver, good. I don't like it. CCK goes to Brittany, the gallbladder, Michael, the pancreas. We clear on that? The other thing Shailene sent out was secretin. Y'all with me on that? Now secretin, as the second hormone, goes to Alicia, which is the liver, and makes bile. And goes to Michael. So we can get pancreatic juice and pancreatic enzymes and shit. Is Shailene happy now? Because Shailene has an intestinal mucosal cell and enteroendocrine cell releasing hormone. Needs help. And what you got now? I got this chyme that Heather sent down. And it's acidic, it's pH 2. And we got a little bit of the tuna broken up, the protein broken up, and that's it. Shailene needs help. She sent out messengers, Brittany, Alicia, Michael, and they all send bile, pancreatic juice and enzyme. And by the time we get to Daniel, here, tell me about the consistency of chyme. What's the pH? 7. Are there enzymes here? Yeah, Michael sent some enzymes. Is there bile in here? Sure. Is that concentrated bile from Brittany? We got bile from Alicia, and Michael sent pancreatic juice, and it's full of enzymes. And what happens in the intestine? Segmentation and peristalsis. Peristalsis is moving. So now the chyme is here. pH of 7, full of enzymes. It's emulsified. And we start doing what? By hydrolysis, breaking down food and absorbing. And it goes into the blood vessels in the mesentery, write that down on the exam, mesentery surrounding the intestine. Mesentery is the peritoneal membrane that is full of blood vessels. Now, can you see it? I'm a tuna sandwich that's been broken down and absorbed, and I'm in the mesentery blood vessel surrounding the small intestine. And where am I going? Where am I going? Brittany, Alicia, or Michael? I'm going somewhere. Am I clean? I'm absorbed, I'm not clean. I'm going to Alicia. She's the liver. And that's called the hepatic portal system. And I'm in the portal venule, where I'm gonna get clean, mixed with arterial blood, and absorbed for storage. That's how we do it. You guys put all that together? If I didn't get absorbed, broken down, I'm gonna go down another chute of the large intestine. Those are where they can digest. Go ahead.
I have a question.
Yeah.
So the hydrolysis and absorption in the small intestine happens prior to the cleansing in the liver.
Correct. Good. So that's why I like that picture. You guys get that? I don't know if you can visualize what I'm doing, but I'm trying to explain it to you in a way that I see it. And since I wrote the test, that'd be a good idea. But right here is Shailene. She got this acidic chyme in here and said, "Whoa, I need some help." And how you get help in our bodies, you send out hormones because they're systemic and they travel in the bloodstream. And she sent out 3 hormones. And those hormones have target tissues. And each of the target tissues has specific functions that we'll get back to Shailene and Daniel so that we can absorb the food. We good? So, there's the hepatopancreatic ampulla and sphincter. And that's where all of those help units came from and how they get into the small intestine so that we can start the process. CCK is secreted in your huge. Sorry, I messed that up. And you're right, CCK does go to the liver, but I don't want you to remember that because it's not part of our DNA. There's the same idea with CCK. CCK and secretion. It's all in your book. Nothing on the rectum. These are good. We just gotta finish. We're only about 5 minutes left. This is the lab. There's a good matching section. So you'll basically wanna
want to do it like this, where you start out with starch and sugars, and you wanna tell me what enzymes affect each substrate. You guys know the term substrate and subunit? We did the lab. If you did the lab, you're fine. Substrates, enzymes, where the enzymes come from, and what the products are. Can you do that for each one of the substrates that we talked about? We did 3 of them in the lab. You want to add nucleases in there, we did that one too. Substrate protein, pepsin, which comes from the stomach. Is it released as an active pepsin? No, it's pepsinogen, all right, inactive, so we don't break down the cell wall. Comes from the stomach. Holy cow, we got pancreatic enzymes. Did Shailene call for the pancreatic enzymes? She sure did, she sure did. Because when she got this tuna sandwich down here in the small intestine, she sent out CCK and secrete, and that went to Michael. And you sent chymotrypsin and trypsinogen, inactive precursors down to the small intestine. Those are the hormones that came there. I also have in your notes freshwater enzymes, which I don't remember asking about on the exam. Of fat. Butter, fat, cheese. You have pepper jack cheese on this tuna sandwich. You swallow it. Gets into your, what's the first place we can have? We can have lipase. We can have salivary lipase. But nobody chews it long enough. pH, functional pH of 7. And it comes down. Nothing happens in the stomach. And so we're basically still fat when we get to the small intestine. Now we got pancreatic lipase, which came from Michael, which was the pancreas, because Shailene called Michael and said, I got some cheese coming down here. I'm gonna need some pancreatic lipase. What type of cells make lipase? Man, you connect the dots, people, it's an easy test. What cells of the pancreas make lipase? Acinar cells. Acinar cells. Not islet cells, they make glucagon and insulin. Alright? So the enzymes come from Michael, who's the pancreas, and it's the acinar cells. Can you identify on the slide acinar cells? Yeah. Are they endocrine or exocrine? Exocrine, because they're released into a duct. Is there a duct connecting Michael and Shailene here? Anybody name that duct? Pancreatic duct. Piece of cake. So Michael makes enzymes in the acinar cells and sends them down a chute. And that chute opens right here at the hepatopancreatic sphincter or the sphincter of Logos. Floods it in. That easy. That's how it works. Acinar cells. Good. pH. Pancreatic lipase. You did the lab. You tell me. Lipase works best at a pH of 7.0. What else are we getting in here? Wow. Because in order to break down fat effectively, we have to emulsify it first. Did Shailene call for some bile? She did. And I think Brittany sent bile all the way down here. Anybody know how bile gets from Brittany to the small intestine? All the way over there?
Common bile duct.
Cystic duct, common bile duct, hepatopancreatic sphincter. Floods in. Got all this stuff here. Bile, we emulsify the fat. Emulsified fats go from large fat droplets to small fat droplets, which increases the surface area so that lipase can come in and break them down and give us our sub-unit products of fat breakdown of fatty acids and glycerol. Are we now able to absorb fatty acids and glycerol subunits in the small intestine? Yes. Specifically, circling back, what structure
of the small intestine aids in absorbing fat. You already wrote this down. You already drew it on your picture today. I told you, green thumb of the Billis model is called a lacteal, and lacteals aid in absorbing fatty acids. We good? Can you do this for each of the substrates that we've covered? On Wednesday, I hope you can.